Today we're going to be talking about function rules. This is day number 2. Our content objective is students will be able to find function rules given a graph. You kind of experimented with it a little bit yesterday when we were trying to find the function rule based off of a table, so today won't be too much of a stretch. Our language objective is students will be able to verbally use correct vocabulary when discussing function rules. And why am I learning this? Well, it's important for solving real-world problems, such as calculating how much money you will earn working a certain amount of time. So first, let's go over some background knowledge. So far in Unit 2, we've talked about how to determine if a relation is a function based off of a set of data, whether it was ordered pairs, tables, or mapping. You know that I feel as though mapping might be the best way to kind of illustrate that. So here, a lot of students may find this to be a little difficult figuring out if it's a function or not. Why? Because they see all of these arrows at 5 and they automatically think, oh, it probably isn't a function. So I always suggest my students block off this for a moment and just ask yourself, is there more than one output for 0? Nope. Is there more than one output for 1? Nope. Is there more than one output for 2? No. Is there more than one output for 3? No. So that means every input has a unique output. Therefore, this one is a function. So I would say that this is a function. So don't let these arrows to the output confuse you. And again, just simply use your hand, cover this side up to see if each input has its own individual output. Okay, so now something we've also talked about was how to determine if a relation is a function based off of a graph. And we used the vertical line test to test that. So in this case, this one would pass the vertical line test, which means it would only intersect the vertical line once, so this one's a function. However, this one, if we drew a vertical line, we would find that it would not intersect only once. In this case, it would intersect twice, once here and once here, so we would say this one's not a function. So now, we've also discussed different terminology for x values and y values. For the x values, we do call them input, which are also independent variables. And for the y values, we refer to them as outputs, and we know that those are dependent variables. Fourth thing we've talked about is how to determine a function rule from a table of values. We did work on that yesterday. And we've also even reviewed proportional relationships. We've mentioned that proportional relationships are linear, meaning they're a straight line. They go through the origin, 0, 0. They're in the form of y equals mx or y equals kx. This is what you've learned in 8th grade. You did see this in 7th grade, but they're the same thing. And of course, we always check to see that ratios y over x are all equivalent. So let's quickly go over some of the examples that we went over yesterday. So in this one, our function rule was y equals 2x. This is a proportional relationship because y follows the form y equals kx or y equals mx, same thing. If I wanted to check the ratios, if I check the ratios as y over x, so here negative 2 over negative 1, this is 2. Here we're not going to check 0, 0 because that would be undefined. You can't divide by 0. Here it would be 2 over 1, which is 2. And the last one would be 4 over 2, which is 2. So notice, since my ratios are equivalent, just using y over x, it is a proportional relationship. This further proves that it is. Now, taking a look at this one, also pulled from yesterday, we found that the function rule was y equals 3x plus 1. Okay. For some, you may have had to graph it to see because it might be difficult for you to generate this on your own. So this would be another option. But real quick, let's check to see if the ratios are equivalent. Again, we're just going to check y over x and see what happens. We have negative 5 over 2. Sorry, negative 5 over negative 2, which would give me 3, nope, not 3.5, 2.5. We won't check this one because this would be undefined. then we would have 7 over 2, which is 3.5. So already we can see that the ratios are not equivalent. That's why it's not a proportional relationship. But if you wanted to check the last one, 13 over 4, this would give me 3 and 25 hundredths. So again, these ratios are not equivalent, therefore we can say that for sure it's not a proportional relationship. But of course there's other methods. We can see here clearly in our graph that it's not going through the origin. So there's another reason why it's not a proportional relationship. Okay, so now on to the new stuff. If you're trying to find the function rule, which is essentially the linear equation of this graph, what you're going to do first is find the slope and then find your y-intercept so that you can put it into your equation of y equals mx plus b. So, got to make sure we remember slope-intercept form, y equals mx plus b. So I need to find m. M is your slope. So first of all, I noticed that it is going to be positive since it's going up. But let's go ahead and count. It's going up 1, 2, 3. Since it's going up 3, that's a positive 3. And then it's going over 1, 2, 3, 4, 5 to the right. So my slope is positive 3/5. But what about my y-intercept? Well, the y-intercept occurs right here, which is 0, -2. So I would say b is -2. So what's my function rule? All I'm going to have to do is put this together into slope-intercept form. So my equation would be y equals 3/5 x minus 2. Now real quick, what we can do is talk about some of the solutions. So obviously these two given points would be solutions. So I would say 0, -2 is a solution. Let's see, 1, 2, 3, 4, 5, 1 would be a solution. Are there other points? Let's see. If I went up 1, 2, 3 over 1, 2, 3, 4, 5, I can go the opposite. So 1, 2, 3, 1, 2, 3, 4, 5. So this one would be -1, 2, 3, 4, 5, down 1, 2, 3, 4, 5. So another ordered pair might be -5, -5. So all of these are solutions. So basically solutions are your ordered pairs that fall within your line. Please understand these are also ordered pairs. They're just a little bit more difficult to pinpoint exactly what that ordered pair is, and that's why we tend to pick ordered pairs that fall directly on an intersection. Okay, so what about this one? Okay, so I'm going to show you one more time. What we're going to do is find the slope. We're going to find the y-intercept and simply use slope-intercept form to generate our equation or function rule. So what is the slope? First of all, I recognize that it's going to be positive since my line is going up. So I'm going to find the vertical change, which is 1, 2, 3, 4. Since it's going up, that's positive 4. And then it's going to the right 1, 2, so that is a positive 2. So notice here, this can be reduced. 4 over 2 is going to leave us with 2. Now I need to find the y-intercept. That is right here. The y-intercept is at 0, 3, so b would be 3. So I'm going to say that's 3. So now that I have slope and now that I know what b is, I'm going to go ahead and plug it into my slope-intercept form and say that y equals, instead of m, I'm going to put 2. X, instead of putting b, I'm going to put plus 3. So now real quick, let's discuss some of the solutions. Obviously, the ordered pairs that are already given would be solutions. So a 1, 1 would be a solution. This would be a solution, which is 1, 1, 2, 3, 4, 5. So 1, 5 is solution. Now notice there are others. Maybe this one would work, which is going to be 0, 3, which is our y-intercept. This would be a solution, which is 2, 1, 2, 3, 4, 5, 6, 7. This would be a solution, this would be a solution, this would be a solution, and this would be a solution. So you could essentially write all of them down. just understand all of these points are solutions to this function rule. Okay, so now I want you to go ahead and try number 2, pause the video, and see how well you do. Okay, so let's see how well you did. So for the for the function rule, we need to find slope and we need to find the y-intercept. And we're going to use slope-intercept form, which is y equals mx plus b, to figure out what our function rule is. First things first is find the slope. First, I want to recognize that it should be negative since my line is going down. So let's go ahead and count the vertical change. It's going down 1, 2, 3, 4. Since it's going down 4, that's a negative 4. Then it's the horizontal change is 1, 2, 3. Since it's going 3 to the right, that's a positive 3. Negative 4 over positive 3 is going to be a negative 4/3. Then I'm going to look for b. Okay, b is right here. The y-intercept is 0, 3. So b is 3. So now that I know both, I'm going to go ahead and write my function rule using slope-intercept form. Y equals negative 4/3 x plus 3. So what are some solutions? Well, we could of course use the given points here. So this one would be 0, 3 would be a solution. Positive 3, negative 1 would be a solution. What else can we find? So if you're unsure at all, you can always use the slope. So instead of going down 4, you can go up 4, 1, 2, 3, 4. Instead of going to the left, instead of going to the right, you can go left 3, 1, 2, 3. So basically, I'm using the slope to find these ordered pairs. So 1, 2, 3, 4, 1, 2, 3. So this ordered pair would be negative 3, 1, 2, 3, 4, 5, 6, 7. And this last one would be 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. So that'd be a negative 5. So once again, all of these are ordered pairs, which also are solutions. So once again, I would like you to go ahead and pause the video and try this example on your own. Okay, so now let's see how well you did. So hopefully you went ahead and found the slope. In this case, my slope is going to be positive. It's going up 1, 2, 3, 4, 5. So that's a positive 5. And then my horizontal change is 1, 2. Since it's going to the right, that's a positive 2. Then we are looking for b. So what's the y-intercept? The y-intercept is 0, negative 3. So b is going to be negative 3. Now that I have both, I'm going to go ahead and write the function rule using slope-intercept form, which would give me y equals 5/2 x minus 3. Once more, we're going to go ahead and write down some solutions, which essentially are your ordered pairs. So this one here would be 2, 2. This one here would be 1, 2, 3, 4, let's see, 1, 2, 3, 4, 5, 6, 7. There's one here. This was the y-intercept, so that's going to be 0, negative 3. And that's the last one that I see. So these are the solutions to our ordered pairs. Please, once more, understand any point on this line is a solution. However, some are more difficult to pinpoint exactly what the ordered pairs are. So we do tend to pick the ones that fall exactly on an intersection that we can easily determine. Okay, so now looking at this one, we're going to do the same thing. However, they don't have ordered pairs for us. So you're going to have to find these points on your own. So we're still going to find slope. We're going to still find the y-intercept. First thing that I'm going to do is pick 2 ordered pairs, preferably 2 closest to each other. I'm going to go ahead and pick this point and this point. Notice I purposely chose one on the y-intercept because that's also going to be what I'm going to use to find out what b is. So here, Now that I have 2 points, I can figure out what slope is. It is a negative, it's a downhill line, so my slope's definitely going to be negative. It's going down 1, so that's negative. It's going to the right 1, so that's positive. So my slope is a negative 1. Then I'm going to figure out what b is. B, the y-intercept here would be 0, 1, 2, 3, 4. So b would be 4, so I'm going to say b is 4. Now that I have that, I'm going to go ahead and write my function rule, which is y equals negative, instead of 1, I'm just going to put negative x plus 4. So once more, I can go ahead and write down some of the ordered pairs. You're going to find some nice intersections. So all of these are some solutions to the graph. All of these are. I won't list them all for you. I will just list a few, but understand all of these points are ordered pairs. So here, 0, 4 is a solution. 1, 3 is a solution. Negative 1, let's see, 1, 2, 3, 4, 5 is a solution. There are more to be listed. However, I just wanted to show you real quick what some of them were. And that's it. So hopefully you can try number 5 on your own now. So go ahead and quickly pause the video and try to find out the function rule on your own. Okay, so let's go over the answers. First things first, we're going to find our slope and the y-intercept so that we can plug it into slope-intercept form to develop our function rule. Here, in order to figure out slope, I want to pick at least 2 points, preferably close to each other. Here, I notice there's going to be a vertical change of a positive 2 since it's going up, and a horizontal change of 1, positive, since it's going to the right. So positive 2 over positive 1 is going to reduce to 2. What is b? Here, notice is going through the origin. So that would be 0, 0. So in this case, b is 0. So in order to write my function rule, I would write this as y equals 2x. There's no point in putting plus 0. So notice here, I would definitely say that this is a proportional relationship. How do I know this? Well, first of all, it's linear, meaning it's a straight line, and it goes through the origin. So real quick, what would some solutions be? This one would be a solution, 0, 0. 1, 2 would be a solution. This would be a solution which is 2, 4. This would be a solution which is 4, 6. This would be a solution which would be -1, -2. This would be a solution, and this would be a solution. So again, I'm not going to list them all for you, but you understand any of these points on the line are solutions to the function. Okay, so now go ahead and pause the video and try number 6 on your own. Okay, so let's see how well you did. We're going to go through the same steps. Find slope, find the y-intercept. I'm going to pick 2 ordered pairs fairly close to each other. Picking these 2 here. To find the slope, I'm going to have to go down, which is a vertical change of -1. And then it's going to go to the right 3. So that's my horizontal change. So this is going to reduce to -1/3. Now in order to find b, which is right here, the ordered pair would be 1, -1. So b is -1. Now that I have both, I can go ahead and make my function rule using slope-intercept form. So it's going to be y equals -1/3 x minus 1. So now I'm going to list some more solutions. So here, that solution would be 0, -1. This one would be -3, 0. This is a solution as well, which is -6, 1. This is also a solution, which is, let's see, 3, -2. And the last one that I can see within my graph would be -6, -4. So are there infinitely many solutions? Absolutely, because these lines would extend until infinity. So there are more solutions to be found. And again, you can always pick points in between. They're just very difficult to pinpoint what these ordered pairs are. But notice there's infinitely many solutions within the line. Okay, so now they're asking us to find the function rule that passes through two given points. So what we can do is go ahead and graph it and then do what we've been doing earlier. So I'm going to graph 1, 3 and -5, -3. Now that I have these 2 points, I'm just going to go and extend my line. Now with this, I'm able to figure out what my slope is and what the y-intercept is. So here, what's my slope? It's going up 1, 2, 3, 4, 5, 6. Since it's going up 6, that's a positive 6. Then it's going to the right 1, 2, 3, 4, 5, 6. It's going to the right, that's a positive 6. 6 over 6 is 1, so my slope is a positive 1. Now we have to figure out what b is. Here is the y-intercept, which is 0, 2. So b would be 2. So now that I have this, I can say my function rule is y equals, I'm not going to put 1x, I'm just going to put x plus 2. So that is my function rule. And that's it. So now, given that, I would like you to go ahead and try number 8 on your own. Okay, so let's see how well you did. Hopefully the first thing you did was plot the 2 points, draw your line, find the slope. So in this case, my slope is going to be going down 2. Since it's going down, it's negative, and then it's going to the right 1. Since it's going to the right, that's a positive 1. -2 over positive 1 is -2. Now I need to find out what b is. The y-intercept in this case is 0, -1. So b is -1. So my function rule using slope-intercept form is going to be y equals -2x minus 1. So that is my function rule, and that's it. So now, real quick, thank you again for tuning in as always, and until next time, bye.